This video is for Chemistry in the Earth System, Unit 3.4, Lewis Structures and Molecular Geometry. Today's essential question is, how are Lewis structures used to show bonding and non-bonding valence electrons in molecules and ions? Our first main idea, Lewis structures. A Lewis structure is a kind of shorthand for showing the details of various types of bonds. This method is especially useful for showing covalent bonding between non-metal atoms, as is formed in most organic molecules. Remember that atoms are most stable when they lose, gain, or share electrons to complete their outer, or valence, shell. Noble gases are stable and unreactive because their outer shell of electrons is already full. For the second and third rows of the periodic table, a complete valence shell has 8 electrons, and for the first row, a complete valence shell has only 2 electrons. To use Lewis structures to predict bonding in a molecule, begin with the structures of the neutral atoms. For example, consider the structures of nitrogen and hydrogen, which combine to form ammonia, as on the screen here. Nitrogen is 3 electrons short of a complete shell, meaning it comes with 5 because it's in group 15 or 5A. And hydrogen is 1 short because it only has 1 valence electron. So the following combination will give them both, and by following I mean the one on the screen here, will give them both a complete, stable valence shell. The pairs of electrons between atoms represent bonds, and the other pair, which is shown on top of the N here, is a non-bonding pair because it is not involved in a bond. Showing bonds as a line between atoms is equivalent to showing 2 dots, meaning they are the same thing. Bonds can also have more than 2 electrons. Double bonds have 4 electrons and are represented by 2 lines. Triple bonds have 6 electrons and are represented by 3 lines, which we'll show on the next screen. Double and triple bonds are less flexible than single bonds. Double bonds in general have higher bond energies and are shorter than single bonds. And triple bonds have even more energy and are shorter than double bonds. Some examples of those are on the screen here. These are the Lewis structures for carbon dioxide on the bottom right and hydrogen cyanide on the top left. Ions can also be represented by Lewis structures. For example, the non-bonding electron pair in NH3, which we showed on an earlier slide, can attract a positively charged hydrogen ion to produce the stable ammonium ion, which is shown on your screen here, NH4 with a +1 charge. Lewis structures, sample problem. Draw the Lewis structure for CH2Br2. The first thing we'll do is determine the type and number of atoms in the molecule. This formula shows 1 carbon atom, 2 hydrogen atoms, and 2 bromine atoms. Next step, we'll write the electron dot notations for each element in the compound. Remember, we can use the periodic table to determine the number of electrons in the valence shell of each element. Carbon has 4, hydrogen has 1, and bromine has 7. In our next step, find the total number of available valence electrons in the atoms that we'll be combining. So we just established that there's 1 carbon with 4 valence electrons, 2 hydrogens, each with 1 valence electron, and then 2 bromines, each with 7 valence electrons. So 4 electrons plus 2 electrons plus 14 electrons means that there are 20 available valence electrons for this molecule. Next step, we'll arrange the atoms to form the molecule. Here, carbon will be the central atom. Remember, if carbon is not present, the atom with the lowest electronegativity will be the central atom, except for hydrogen, because hydrogen is never the central atom. Once we have the skeleton formed, we can use electron pairs to form bonds. Next step, we'll add the remaining electrons, because we only added the bonding electrons, and we had 20 to deal with. we'll add the remaining electrons around the atoms in the molecule so that each hydrogen shares one pair of electrons and the other atoms have an octet. But be sure to only use the available electrons, meaning the number that we have left over. And so we'll have a structure like we see on the screen here. And lastly, we can double check to be sure that the number of valence electrons equals the number of available electrons. Again, the 20 electrons that we established at the beginning of the sample problem. Be sure that all atoms except for hydrogen have a full octet. At this point, you should be able to generate a full and appropriate response to today's essential question. How are Lewis structures used to show bonding and non-bonding valence electrons in molecules and ions?